Prime factorization. In this video, our objective is to determine the prime factorization of composite numbers. Well, there's a lot here, particularly when it comes to definitions. So let's take a look at some definitions that we're going to need to know in order to understand what this objective means and to follow through on it. Okay, first things first. The word factor is both a noun and a verb. We're going to define it here as a noun. So the factor as a noun is something, it could be a number or a letter, that is multiplied. Okay, so here's an example. 2 times 8 equals 16. Well, 2 is being multiplied. It's being multiplied by the 8. 8 is being multiplied. It's being multiplied by the 2. So the numbers 2 and 8 are factors. And they're both factors of 16 because they're multiplied to give you 16. So they're factors of 16. Okay, next up, what's a prime number? Okay, a prime number is a whole number that's greater than 1. So we're talking about 2, 3, 4, 5, 6, 7, 8, etc. Those are your whole numbers greater than 1, whose only factors, okay, the only way they can be found through multiplication, whose only factors are 1 and itself. Another way of saying this is a prime number is a number that cannot be made by multiplying other whole numbers other than 1 in itself. Okay, so your first 5 prime numbers, again, were greater than 1. 2 is a prime number because 2 can only be created by multiplying 1 times 2. 3 is your second prime number. You can only create 3 with multiplication by 3 times 1. And then you go to 5 to 7 and then 11. So those are your first 5 primes. I think number 6 is 13, and then you go to 17, etc. And again, take the number 11 example. The only way you can multiply 2 whole numbers to get 11 is if you multiply 1 and 11, 1 and the number itself. Okay, back to our objective. Our objective also mentions composite numbers. Okay, what's a composite number? Well, basically, if it's not prime, it's composite. A composite number is a whole number greater than 1, again, 2, 3, 4, 5, 6, etc., that has at least one other factor in addition to 1 and itself. Okay, so our prime number only had 2 factors, 1 and itself. A composite number will have to have more than 2 factors, 1 in itself, 1 and itself, and then at least one other number. So here are a couple of examples. 4 is composite because, of course, 1 times 4 is 4, but also 2 times 2. So 2 is a factor of 4. 6 is a composite number because 6 has 4 factors. We can make 6 by saying 1 times 6, but we can also create 6 by multiplying 2 and 3. So it has 4 factors. Okay, you'll notice just a brief remark here. You'll notice that the number 1 isn't included in either location. Essentially, 1 is neither a prime number nor a composite number. Just something to kind of store in the back of your head there. It's not prime nor composite. Okay, so now that we know what a prime is and what a factor is and what a composite is, let's talk about what prime factorization is. So prime factorization, it's a process. It's the process of writing a composite number as the product of only prime numbers. So you want to take something like 6 and write it as a product of only primes. Okay, let's take a look at how it's done. Let's do a few examples here. Get my paper straight up. Okay, find the prime factorization of 30. I'm going to show you a couple of ways to organize this that might, hopefully one of the two will make sense to you. It kind of depends upon maybe how you've seen it before, or maybe how you like to organize things. One way people do this is with tree diagrams. So start with the number 30, for example, and simply break it apart as a multiplication problem. And you can choose to do it any way you like. 30, of course, we want the prime factorization. And we know if we do 1 times 30, we don't get anywhere. And 1 is not a prime. So you can start and you could say, well, 30 is even. 2 times 15. Many of you may also realize 30 is 3 times 10. And some of you may start off with the fact 30 is 5 times 6. It doesn't matter. I'm going to do 30 as 3 times 10. And no matter which way you do it, you'll have the same result in the end. And then whenever you see a prime, well, I know, if I go back to here, I know the first 5 prime numbers are 2, 3, 5, 7, and 11. 3 is a prime number. All right, so I'll go back to here, get my paper straightened out, and I'll say, okay, well, 3 is a prime. So that's going to be a stop there. 10 is a composite. 10 is even. Okay, 10 has more factors than just 1 in itself. Well, 10 I can write as 2 times 5. And 2 is a prime, and 5 is a prime. So I've just finished. I have no more, I'm all dead ends. I have circles at every end of the branches. This is a kind of a tree diagram type display. And so the prime factorization, which tells me this is the process of writing a composite number as a product of only primes. The prime factorization is going to be 2 times 3 times 5. It can be written this way. I've seen some people write it as 2 with a dot. That way as well. And normally people write it numerical order. The smallest number comes first, and then and work your way up to the largest number with your primes. So that's one way to do it. This is the prime factorization of 30. 2 times 3 times 5. 30 as a product of primes is 2 times 3 times 5. Another way you might choose to organize it that I've also seen done is some people will go like this. And I like to start with 2. So I know my first primes are 2, 3, 5, 7. So I'll do 2 until it's no longer even. So 2 goes into 30 15 times. Well, 15's not even, so I check 3. 3 goes into 30, 3 goes into 15 5 times. And once I get down to where I know this is a prime number, then I'm done. So I can see here, 2 is a prime, 3 is a prime, and I finished with a prime. And so I know my prime factorization is 2 times 3 times 5. Your choice on how you want to organize it, those are 2 ways that I have seen. Okay, let's take a look at another example. Slide up a little bit here. How about example 2? And I'll do both ways for each of them. Okay. Find the prime factorization about of 16. Okay, I'll do it this way. Oops, I got a little ahead of myself here. I think I'll do it this way first with the kind of the tree diagram. Start off with 16, and I'll say 16 is, well, for me it's easy. It's 4 times 4. Now you could do 8 and 2 if you wanted to. That's totally fine as well. I chose to do 4 times 4. Neither of these are prime, so they can both be, I can branch from both of them. 4 is 2 times 2, and this 4 is 2 times 2. I'll use an X or a dot there. And of course, these are all primes. So my prime factorization is 2 times 2 times 2 times 2, which we can also write simply as 2 to the 4th power. Make it a little bit simpler. This is just simply 2 to the 4th power. The other method here, if you want to start off with 16, again, I like to start off with my first prime and work until I'm done with it being even. 16 divided by 2, well, that's 8. 8 is still even, so I'll divide by 2 again, and that gives me 4. 4 is still even, so I'll divide by 2 again, and that gives me 2. I ended up on a prime, so I must be done. 1, 2, 3, 4 2's, and this is also 2 to the 4th, and that is the prime factorization of 16. The number 16 written as a product of primes, 2 times 2 times 2 times 2. Okay, last example. We'll get a little bit more difficult. Let me see if I can fit this one in here. Okay, well, look at my paper. Find the prime factorization of we're going to do 132. And again, I'll do it in both methods. 132. Okay, so I'm going to put 132 here and do my tree diagram. Wow, 132. Well, I happen to know that 132 is 11 times 12. So I'm going to do 11 times 12. Now you may only see a 2, so it's 132 divided by 2 is, let's see, 66 maybe? You may see that. I know that 132 is 11 times 12, so I'm going to start there. It doesn't matter. 11's a prime. Did it pop up here? Oh yeah, sure did. It did pop up here. The 5th prime is right here. 11's my 5th prime. So I can circle that one. That's a prime number, but I know that 12 is composite. And I'll say that 12 this time, let's say that 12 is 6 times 2. And I know that 2 is a prime. I know that 6 is composite. And of course, 6 is 3 times 2. So now I've taken my tree, my 132, and I branched it off until I have all primes at the ends. And if I start in order, I have 2 2's. So 2 times 2. My next prime in order is a 3. And then I wind up with an 11. 2 times 2 times 3 times 11. So the prime factorization, well, I have 2 2's, that's 2 squared, times 3 times 11. The other method, okay, if I start off with 132, and again, I like to just say, well, it's even. Okay, 2. How many 2's in 132? Well, if you don't know, pull out a calculator. You know it's even, so you know it divides. Well, 2 goes into 132, as I said, I think it goes in 66 times. Okay, well, 66 is still even, so I can do 2 again. 2 goes into 66, 33 times. 33 is no longer even, so now I go to my next prime, which is 3. Is 3 a factor of 33? Yes, it is. It's 3 times 11, and I know that 11 is a prime, so I'm done. And you can see here 2 times 2 times 3 times 11, so 2 squared times 3 times 11. And there you have it. That is how to determine the prime factorization of composite numbers.